Okay, when it comes to the Airborne QC module in Geosoft, how you get it to load up, because it's an additional menu, go Manage Menus, and you click here under Extensions on this Airborne Quality Control QC, click OK. It'll load the menu, and it lists it up here towards the right-hand side. And so there's two aspects to this menu. This first two options of the submenus here are to generate flight path plan. And so this is when you haven't gone into the field yet. A client has asked you for an estimate of what it's going to cost, how long it's going to take, what your flight line spacing is going to be. And so here you can actually develop this plan and get a statistics on it. And then this third option here, QCing, is once you've gone to the field, you've collected data, you come back and you're comparing it to how it compares to your original estimates and what you told the client you were going to collect. And that's this menu here. Calculate deposit response is an additional option to just give an estimate of what you're likely to find in the field area. And so let's start with this first option here, generate flight path plan. First option here, create boundary file. You can either import an AutoCAD DXF file of the boundary of your survey area, or you can digitize the boundary. So I'm going to click on digitize, and you can see here, I'm assuming the client has given you the coordinates of your survey area, and you've used the seeker option here in Geosoft to download topography data, and so this is the area I'm going to be surveying. Let me actually, I'm just going to take off the paths because you haven't flown anything. You haven't even been to this area before. So you go Airborne QC, generate path, create boundary file, digitize boundary. Give it a name. I'd say don't just call it boundary because maybe you're going to do this for several different areas. So give it a name. Inclusive, you're going to look at all the areas inside this block. Click New File. It says enter the point on the polygon. Right click when you're done. Escape if you need to cancel. Click OK, and I'm going to click on the boundary of my polygon. And right click, done. I don't want to add anything more to this polygon. This is the only area I want to look at. Okay, then you go back here and you go down to create a survey plan. It's loaded in the boundary file you just created. Now it's asking you what are your parameters. What do you want your flight line spacing? You can choose. I'm using 1,000 because we are trying to pretend like we haven't been to this area before and then pretend we're going to go collect data, but actually in real life we've got the data already. So I'm going to use the parameters from the survey. So they flew with 1,000 meters line spacing, but you can choose yours, and the flight directions were north-south. Tie lines, I do want tie lines, so I click on the I add a plus over here. I know their tie lines were every 10,000 meters, so obviously not as often, and at 90 degrees to the original flight lines. We're not going to click on this Drapes survey altitude. We'll do this at a later stage, and then define an output database. I call it flight line Karoo 2, so I know what where the flight lines are generated for, and a map called survey plan Karoo 2. Click on this More button. The sampling spacing of 13 is a default from Geosoft, but you'll know for your instrument how often it's going to sample. It's obviously this is in meters, so if you know it samples every 2 seconds, you're going to have to take into account how fast you're flying to know how many meters it samples. Do you want to extend your lines outside of this boundary block? I'm going to say 0 because I don't want to extend it. What is the initial flight line number? So this first line, what am I going to call it? So you really can call it 0 or 100 or 1,000, but in the survey I've got, I know their first line is 6,200. So I'm just putting numbers so I can easily compare this database over here that's generated with the existing data I have. But you won't have existing data, so you can define this. The flight line increment number, how much must it label by? So it's going to go 6,200, 6,300, 6,400. X and Y waypoint, you can read about this in the question mark on the help. It's if you've got a specific point you definitely want it to be included on your survey line. Tile line numbering, again, this is what they used in the survey I've got. You can call it, but just call it something a few orders of magnitude different from this value here. So if you've got 100 here, maybe use 1,000 or 10,000 over here, just so you can see a big difference between, oh, this is a line number, this is a tile line. Your line numbers will be labeled with an L and your tile lines with a T, so it is quite easy to separate them. and I'm also going to increase this in 200s. So let's click OK. Mine says, do you want to overwrite? Because I've done this already, but yours shouldn't ask about overwriting. And let's just give it a moment as it creates the file. It's going to give us a map of the flight lines and a database of the flight lines. Okay, so here's our map. Okay, so north-south are our flight lines and east-west are our tie lines. Red is the boundary. The values are actually listed there. I can even zoom into the values. And on the left here is the actual database of the XY values. And if I go here to the L6200, right click, go to list, you can see all the line numbers. And so this is what you're going to give the client. Okay, so you can see here I've plotted up in red is the eTopo column that was in this database to start with, and then in grey is the eTopo from the seeker data that I've downloaded over here in GeoSoft. And you can see my eTopo that I've got is hang of a lot more low resolution. I can honestly admit this data either came with the original data set or I extracted it from eTopo data, which I think has got about a 90-meter resolution. So the seeker data, I think, was 1 arc minute. I'm not sure. It has much higher resolution, you can see. So I'm going to ignore this eTopo channel. I'm going to remove it here. And so now we're going to look at this drape channel. So if you go to the Airborne QC, generate flight path, calculate drape survey altitude. So you could have done this while you were creating a survey plan, but we chose to click off of it. So let's do it now. So okay, calculate drape survey altitude. Okay, and the input database is this Karoo data, so it's the data you've got in the field. In input topography grid. So okay, so you can see what I'm going to change this to is this SRTM Southern Africa Madagascar, because this is the high res one. Climb gradient. So this should come up with a default of 2, and that is a very gradual climb. GeoSoft people told me, I think that means it's a climb of 2 meters every 100 meters. A climb of 2 meters per every 100 meters, which I think is standard for the small fixed wing planes, but with drones it's obviously very different. If it just goes straight up and keeps going, I would assume that's 100%. And you'll see, if you put this as less, if you put it at 20, 25, it doesn't 100% follow the topography, whereas at 100 it does. So let's actually try, let's do 20. Your choice if you want to add in all these other values, it's not necessary. For this, the nominal height, so this data was collected around 150 meters. Again, you don't have to put in any of these other values. And then you need to give a channel that's going to put the draped values in. So I just called it draped. I've made mine smooth. I've set it as the current Z channel. So I click OK. OK, and it's moaning at me. Does not exist. Oh, sorry, I think I moved it. Sorry, I had things in different places and I tried to consolidate all of it, else I'll never be able to find it again. There we are. Hopefully that works. Let's see. Okay, so it's given us this drape channel. It's automatically plotted it on the map, and you can see it's actually followed really well, even with the climb of 20. So yeah, you can play around with those percentage values. Sorry, let's just go back to it. I want to double check I did use 20. Okay, so that's with 20. Let's put 2, which is the default, just so you can see what it looks like then. You can see it's very jagged. It's not following the topography particularly well. So, okay, I'm interested to see that 20 is actually gives you a good fit, a good drape to your data as well. So let's leave it at 20. I'd assume it would have to be 100 with a drone if you're going to go straight up. Okay, so now we've got this drape, and so this is at the height that your aeroplane, this fixed wing aeroplane, is going to fly over your topography to fix. So the next thing here is that it plotted the plan for you automatically, but if you want to come back later and plot it again, you could use this option. You can also use look at the summary of the plan. So let's display the ideal flight plan. Go over here, go general plan. View summary of the plan. Okay, and so it's giving you all the different lines. It's giving you what x and y value goes from and to, and the total distance of each line, and that they're inside the boundary that we set. The same for the tie lines. Let's look over here at, so you could export your plan to XY file. You can also look at statistics of survey data. So this is, you can either do on your deal data or even your collected data. So survey data, statistics. So probably ideal to do it on the stuff you've already collected. So I've clicked on my the data was collected in the field, Airborne QC statistics of survey data. Here you can choose one channel from the drop down, or you can do multiple by putting a comma. So let me do long to, I think it might be case sensitive to, and it's going to export it to this file stats. Click OK, and here you can see pretty much what we saw in the previous screen, but let's maybe make it a bit more relevant. Go stats, survey data, let's go here, flight underscore height. I suppose we could also click it from the drop down menu. If you click OK, it overwrites, and so here you're getting your XY data, and it's adding to the end here, flight height, the min and max of each, the mean, the standard deviation, number of points along the line. So you can look at stats of all of your channels. And now we're going to pretend you've gone to the field, you've collected the data, and we want to compare it with your original plan. How well did you collect your data? Did you stick to your flight lines? Did you swerve around a lot? Did your height change, or were you pretty accurate? And so we're going to be comparing this, sorry. So this flight lines database, which is what your original plan was, with your Karoo 2 database. Sorry, you can see I undocked it, that's why I made it reduce. So this database on the left with the real data on the right. Main thing is you cannot compare these unless your line numbers are the same. So if you look at this list, it goes from 6 to 100 down to line 10, 100. So we might have some discrepancies, but 6 to 100 down to line 100, 10,000. So we're missing a line somewhere, but that's fine. Tie line starts at 10, 100, and let's see what numbers they started here. Also 90,100. Sorry about that. But then again, let's plot what they look like on the map so we can see just visually before we start the QCing how they compare. So let's open up our original map over here, and you can remember we've already plotted our residual data. Sorry, that's the derivative. There's our data. I'm taking off the topography data. I think that's actually our RTP data. So I'm actually just going to, this is the original data that we had. Let's make sure I've got the right color bar. Okay, so I'm plotting on here. This is what I plotted earlier. These were the actual paths that I flew, or that the guys flew. Now I want to put on here what I originally planned. How do they compare? So make sure your ideal flight line database is open. Now go Map Tools, Line Path, and let's give it a different color, your choice. I'm going to do it red, and click OK, and it should plot it on the map. And it should also plot the numbers. So let's see how they compare. Okay, so you can see the numbers are very small. Let's go back to line path and let's give bigger labeling. I'm not sure what is ideal. I'm going to put 3, and I'm also going to put the labels in red so we don't get confused. I'm going to overwrite it. Okay, so you can see the lines sometimes match up. This, you can see the flight lines here are very wiggly. Tie lines, there's quite a big gap, which, I mean, you would say, oh, this was flown badly, but we know it's actually just the fact that I'm taking an existing data set and I'm going backwards, whereas actually they would have had the plan and flown according to plan. But the main thing we wanted to compare is these flight lines, and numbering wise you can see the numbers in general correlate. There's a bit of moving around. This one over here, you can see 7, 5, 7, 6 correlate. Earlier on here, because there's so much wiggling, it's hard, but in general they correlate. Okay, so now we're going to QC the data. Okay, so now we're going to look at the next step in the QC the first option in the QC menu, which is this altitude deviation. So if you click on it, there's a hang of a lot of things to fill in, but don't be daunted. This radar altimeter channel, I really did not understand, and I didn't understand the help, so thankfully the guys at Geosoft could explain it to me. You actually have to calculate this channel, and what it is your drape channel minus your eTopo data or your DEM data. So let's close that, let's go back to Geosoft here, go Database Tools, Channel Maths, and you can see I've done it already. I'm creating a new channel that's called Radar Alt, and then I'm doing it is C1 is my draped channel that I've just calculated minus my topography channel. And so it's going to pick up the small variations that you are not going to obviously fly 100% over and above. But then again, if you're a drone and you can't fly perfect to the topography because it's automated, this might not be such a variation for you. So if we click OK, it forms this new channel, and I'm going to plot it as well just so we can see. I'm going to show on profile. See, it doesn't show up, and the reason is of our scale here. It's too big for it. These values are much smaller, whereas your topography is at about 1,000. So if you right click on your plot here, go y-axis, and under profile scaling, the second option here, say scale each profile separately. So each profile plotted on this map must have its own scale. They mustn't have the same scale bar. So if you click OK, you can actually see now, because these values are big and this is smaller values, so it's plotting it all on the same plot. And you can see here is where there's a large amount of variation, for example, and if we zoom in, oh sorry, I didn't push the right button. Oh, I thought I did. Let's see if it works. Okay, and it's here because the red is your topography and the green is the drape. They're on top of each other because you're scaling them to the same, you're not using the same scale. Sorry, they're being plotted on top of each other because we've just changed the scaling option. And so over here they don't compare very well because it's quite a sharp dive, so maybe the plane couldn't follow that topography very well, and that's why you're getting this radar alt deviation over here. Okay, so the next step here, Airborne QC alt deviation, so we're going to go back there. So the radar altimeter channel, make sure you've chosen this one you've just created, this radar alt. Topography channel, I'm using my eTopo seeker data. I'll have to, okay, so this is the data that I've downloaded off of Seeker. My nominal flight height of 150, so that's, I was expecting my plane to have flown at 150. Minimum flight height, so what am I happy about is the minimum flight height. I mean, giving 100, it's quite a big deviation, so it just depends on the specs that you have agreed on with the client. Maximum elevation in your area, I went and checked, and over here where my elevation is highest, so you can see on my map here, was around 1,500 meters. So that's the absolute max elevation. And then, excuse me, these are the variations that you need to define. Like, what are you okay about? So what is your maximum deviation on this flight height that you are okay with? I've got here 500, but 500 is quite high considering I'm okay with my minimum flight height being 100. So maximum deviation that I'm okay with is 20. And sorry, I don't think I explained this that well. This minimum flight height, it's not a number you are coming up with. It's literally a number that you have. You know what the airplane was flying at, and so you need to go look and see what is the average flight height, is this 150? What is the lowest they ever flew? Is this 100? You need to look at that in your flight logs. So this is an actual value, you're not making it up, you actually see it in the data. And again, this maximum elevation, it's an actual data value, you're going through your topography and you're taking out the maximum elevation. If you're not sure how to do that, you could go line by line and look at the actual curves and click on it and at the highest point and see what the values are there. Or on your map here, you could go to where it's pinkest and you're going to right click on the map and go grid value, click there, and in the bottom right it will show you what the height is is there, and you can come up with your maximum elevation value. So this deviation, this is the specs you've agreed with the client. So I've agreed that it can deviate by 20 meters, and like you'll see in the next few QC modules, there's the second option that says allowable deviation over distance. So my whole survey can only deviate by 20, but this one maybe over a distance of 10 meters, I don't want it to deviate more than 5 meters. So yeah, these are specs you've got to have decided on, and then I'm going to click on create new map, click OK. If you don't have any data here, you can click on scan data, it will scan the database, or scan grid, you can choose a database. So let's click here. If I scan it, it literally goes through whatever database is open and it gives values. Scan grid, you would choose the grid for it to look through. It's just getting X and Y values. So for example, any of these should be fine. So I'm just going to use my residual over here and click next. I'm giving it a name. I called mine Alt Dev, so I know what I'm plotting on this map, and I'm going to click finish. I'm going to overwrite because I have done this before. Yours shouldn't ask you to overwrite. Locate the legend, click over here. Okay, and you can see here these blues are all the areas that I didn't, sorry, click save yes, that I didn't fly particularly well, that I didn't live up to the specs that I've set out there. And so zooming in, you can see there. And so it's all the areas where my flight height in green here is deviating heavily from my planned flight height above this topography with my nominal height of 150. Interesting thing that the lady at Geosoft said is she doesn't actually like these maps. She says she doesn't get enough info, and I suppose the reason being is it's one color. It's kind of showing you one value where there's actually multiple values coming out when you do these things. And let me show you, if I go back to my database here and I click on a heading and I right click and I go list, flag height. So these are the flights that are flagged, and let me bring up the help menu here. So we can understand what is it flagging exactly. Okay, so if you scroll down to the bottom, it shows you here. In this column, you're going to have I think 5 numbers you can have. 0 means it passed both of your tests. So it's when you set that deviation value and the deviation over the distance. I can even move this and show you. These two values here, it's passing those tests. So it never deviated that more than 20, and over a distance of 10 meters, it never deviated more than 5. If you get a value of plus or minus 1 in this column, it means you failed the first one. It did deviate more than maximum deviation. 2, it failed the second, 2 or minus 2, failed the second test. 3, it failed both tests. If you get a value of 4, it says flight height is above the maximum elevation, which is this one over here, or it's below the minimum elevation. So I don't know how they determine minimum elevation. I'm sure it's got to do with flight height and topography. And so maybe I didn't actually get this value right that I've put in this 1.5 if the numbers I'm getting out are number 4. And so the lady at GSR said, look, actually it's very good to understand what's actually coming out. By looking at those blue values on the map, you're only getting one number, like one representation of what's wrong, and you don't know which of these 4 are your problems. So she suggested, let's go there, to actually plot this on cross section and to go line by line and see where the problems are. And so how you would do that is you would open up this panel. Sorry, you saw how I did that there. There's all these lines at the bottom. There are actually panels you can expand like this. If you need more space, you can move this one up. And you can see this blue line means I've selected here. If I click down here, it means I've selected the second panel. I'm going to click on this heading here. I'm going to right click and go show profile means it's going to be a smooth curve. She suggested the show symbol profile, and you'll see now it's actual circles, so it's a bit easier to see where you've got 4s and 3s. And so you can see here we've got 4s, so we're failing all the tests. 3s, we're only failing the 2, we're only failing, let's open it up again because I'm not going to remember. 2 means we failed the second test. Down here we're at 0, so we passed both of them. So she just said she really recommended doing this type of plot and going line by line. And again, how you do line by line, you click in this top left here and make sure you click on the line number so it's highlighted, and then push page down or page up on your keyboard so you can go between the lines. The next thing on the QC menu, if you go Airborne QC, is this flight path deviation. So it's saying here, database containing ideal flight paths, which is this one in the background. But we have no way here of selecting the original data. So the reason being is GeoSoft expects the actual data you flew in the field to be open in the background, and you then will select here this database. So we actually need to close here, minimize this, and click on the actual data first. Now you go Airborne QC, flight path deviation. Database containing ideal flight paths is this flight line. Maximum deviation. How much are you okay that they deviate from each other? I'd suggest not doing 10 or 20 for this survey because there's quite a big deviation. But I think when you're flying with drones and it's automated, you're not going to expect a huge deviation. So you could put in quite a low number here. I'm going to put in 200 because our flight line spacing is 1,000 and there's quite a bit of deviation. These second two, for now, yeah, I'm not sure what value is ideal to put in here. I'm sure for drones, again, it would have to be quite small. So this is saying to you, this first one, this 200, is over the whole survey area. If in any place the ideal flight path and the one you flew, if they deviate from each other by more than 200, mark it as being a problem and flag the data. This next option here is saying over a distance, how much can it vary? So over 10 meters, if the plane veered more than 5 meters away from the line, flag the data. So this is really numbers I'm pulling from my head. This would depend on the airplane, on what you've told the client, but I'm just trying to give you an example. I'm going to create a new map here so that we don't get too much data on one map. It can get a bit confusing. You can also leave the second option blank. So what's going to happen is if the data, if it doesn't fit either of these criteria, so it's badly, the two lines don't correlate, it's going to flag it on the map. But then it's also going to create in this database, in this, I think it's this real data over here, it's going to put in a column that says, I'm not sure, it's like deviation flag, something like that, and it's going to put numbers there. I think it's 3, 2, and 1, and 0. 0 is if you've flown very well along your flight lines, there's no deviation, it's a good score. 1 means that it hasn't passed this first test, so there are gaps between the ideal and the flown line of more than 200 meters. 2 means it's failed the second test, that it did deviate more than 5 meters over a 10 meter distance. 3 means it failed both of these. So let's see what that looks like. Click OK. If over here these values are 0, just click on Scan Data and it'll find the min-max of from the database. Click Next, and I'm going to give it a new name here, Flight Path Deviation. And I'm going to click Finish, and it opens up a new map over here. Locate the lower left corner of the legend. You can just click out the area. Okay, so it's telling me QC on the flight path was not carried out on the following line, that one, because either the line doesn't exist or the first 2 pairs of coordinates of the line are dummy. So it's just, I've probably got an extra tie line in this ideal flight path that I don't have in the original data. So I'm not so stressed because it's just telling me one of these lines. If here you get listed every single line in your ideal or in your collected data, it means something's wrong. It means your numbers in your collected data are not at all the same as the numbers in this plan. If it lists all the lines, then you need to go back and check that. I'm going to click OK, and it's going to plot it for me here. Okay, so a lot of green means in a lot of places it failed the test. There were bigger gaps. So let's zoom in. Okay. I don't even know if I can see any areas that aren't green. Oh yeah, there's small gaps here and there. You can see where the two, so over here the black is your survey and this maroon, which I don't think is the brightest color, is your ideal path. And wherever they are further apart than 200 meters, or what did I say, 5 meters on a 10-meter distance, it's flagged with green. So we did very badly at following our criteria. Let's try one more time and just be a little bit more lenient with our criteria. So I'm going to say 300 meters, and I'm allowing a deviation of, I'm even going to say 200 meters over 5 meters. Let's click OK. Next. Finished. It's going to overwrite the map. Every time you go to define the legend, again, that line's giving us problems. I can go delete it from whichever database, because this is just an example. Let's zoom in. Doesn't look too much better. Okay, over here we flew pretty well, and over here, so there are some gaps where we actually flew quite well. So you might, yeah, I suppose you can't go backwards and adjust the QC parameters you promised the clients. And so now you can go to your database here, and it should have added in this extra column. Let's just see, did it? Yeah, flight path flag. So 3 is all the areas that were flagged as green. So I found the easiest thing to do here is plot this column, so show profile, and so you can see here it's going from 3 to 0. So let's see the areas where it was 0. You can see this is where it is on the database. Where is this on the map? So let's zoom out, and it should show us with a cross where it is on the map. So it's, let me click again. So it's down here. You can zoom in. Okay. A reminder that if you click on this button over here and you choose what database to look at, it would be, that's fine. You could use this path database. Click OK. If I click on over here, oh, is it working? Yeah, there we are. You can see it's jumping in the database to where exactly this is. So let's find here. Here's another gap of 0. Oh, maybe it's not looking. See, it's looking over there. See, it's showing you where it exactly is it looking. Okay, it doesn't seem to be very clear. Oh, it's clearly looking. Let's look for another 0 gap. Does it help us jump here? Yeah, you can see here's a 0 gap. So this is where it passes the test perfectly. So let's move on to the next QCing option, QC line separation. So again, you can see what I've got selected is this ideal data. You can see it's slightly dark, even though it's also grayed out. So line separation. Am I looking at survey lines or tile lines? I'm going to look at survey lines for now, because we know our tile lines are terrible. What is the nominal, or what's the average separation? So I know it's 1,000 meters. What maximum separation am I okay with? So I'm okay with 1,200 meters separation. Or here, what about if you look at it over a distance? A line separation greater than something over a distance of something. So I can't remember what I said on the last one. So I'm going to say 50 over a distance of 5 meters. It's probably too harsh. Recalculate distance. I'm not sure about this. I left it as default. Let's do new map. You can check it out under the question mark. Click OK. Again, you can click scan if you don't have values here. Click next. So this is flight line. And we're going to click finish. And I'm going to define my legend. Okay, and let's zoom in over here. I just want to zoom in where the legend is. So pink is when it's flagging the line separation to the left, red is when it's flagging the line separation to the right, and black is the original line path. So you can see over here, there's no color, pink or red, so it's plotted quite, there's not a large separation. It fulfills, the criteria you've given. So go back to the database here, right click, go. You can see closest left, closest right, flag left, flag right. different values that are outputted. So flag left, flag right are the values 0, 1, 2, 3, and again it's about whether it passes one test, both tests, or one test, or the other test, or both tests. Let's look as closest left, closest right. And this closest left and closest right gives the distance to the line closest to the left and obviously closest to the right of this line 9000, the one currently selected. Okay, so that's line separation. Let's close the map and let's go to Airborne QC. Next one along, sample separation. Maximum sample separation. So if you remember our distance channel, let's scroll to it here. If you scroll to the beginning, it's easier to see. So here we've got a distance separation of about 50. Okay, let's scroll up and down the lines. You'll see it does change. So what I do is I click here on the line number, and then I push the up and page down key on my keyboard. So now it's about 50. Here it's about 70 on this line, 60, back down to 60, 50, 60. So I'm going to go Airborne QC, sample separation. So your choice, what the maximum is that you would be happy with. I mean, let's put 80 here. So 80 is too much. New map, click OK. That's fine. Click Next, and I'm going to do here sample spacing. And the new map will come up, ask you to plot the legend. And you can see only over here are there actually problems. Should we try one more time and with a smaller separation? So we're only okay with a separation of 60. Click OK and it'll overwrite the map. Okay, in quite a few places it's white, so it's fine. Quite a few places it's far too much. So maybe in the green areas here the airplane was flying too fast, so the sample spacing it's too large. So the next thing you can do is go Airborne QC, and this flight tie line intersection difference. And so what that's looking is at the point where these north-south lines intersect these west-east tie lines, do the values overlap? I mean, they shouldn't be too far from each other. So let's see this tie line intersection. So the data channel is in your original data. It's going to be the magnetics one. So I mean, for us, we could do residual, or if you wanted to do your micro leveled, maybe let's do micro levels because it's the residual. It will depend on the IGRF. Let's do micro leveled. What is the maximum difference you're okay with? I'm going to plot it on a new map. Let's leave it at 10. Click Next. I'm going to go line tie int, create a map. Okay, and within all of these areas it's below 10, but what I have a feeling, let's just look at these tie lines, what they plot. Okay, so actually, I thought maybe these tie lines didn't have any values at all, but maybe they're actually fine. They really are close. Okay, well, let's try to do a smaller value. So Airborne QC, flight tie line intersection difference. Let's do 5. Create new map, next, finish, overwrite. It makes me a bit nervous. It's never usually this good. Okay, that's a bit more positive, although still concerning. So what we did there was we said flight line difference of 1. So anything bigger than 1 nanotesla, it should flag. And so these purple dots here are where the values are 1 nanotesla different. That's a phenomenal correlation between your tie lines and your flight lines. Okay, so something next on your list here is diurnal drift. I don't have the diurnal values for this survey, so I've got it from another survey, so I just wanted to show it to you. So this is actually the QC tutorial data set from Geosoft, and you can see here they've got a magnetics channel, and they've got a diurnal channel, and they've got a time channel. And so this, ideally I would have a diurnal channel in this database. I don't even think I have a time channel, so I wouldn't have been able to calculate it. So these readings, the diurnal is recorded by a base station that is set up in one place throughout the whole survey. It never changes its location, because that means that this base station is not measuring any change in the underlying geology, because it's in absolutely the same place. So the only thing it is measuring is changes in the Earth's magnetic field. And I just wanted to show you a plot of what the diurnal would look like for the day. Okay, and this is an example plot of magnetic readings that were collected on one of the Wits field schools, and you can see this is over time, so across the day. So probably it should be better displayed from like 8 in the morning to 5 in the afternoon, and you can see the magnetic fields are about 28,800, and here it's 840, and it goes down here to 28,800. So there's a drop of about 40 nanoteslas per day. And that's fine. 40 nanoteslas per day is normal and expected. If you saw sharp changes, that could be due to a magnetic storm, and then you'd be concerned about the quality of the data. Another amount that people usually look at is it should not change by more than 2 nanoteslas per minute. So let's look at our data over here, this other data set. You get Airborne QC, Diurnal Drift. You put in your diurnal channel, your time channel. Diurnal deviation greater than, what did we say, 2 nanoteslas per minute, yeah. So 2 nanoteslas for a chord of time in minutes less than 1 minute. Let me create a new map. I'm going to call it the diurnal. Diurnal. And finish. So this will pinpoint areas where the diurnal was larger than 2 nanoteslas per minute. Oh, sorry, it's plotting on this map, but actually this is this survey over here. So let's just go here. Okay, so I'm not going to be able to plot it on a map because this map is different from the map we're working on, but if you can see here this flag diurnal. You can plot it, and here it's all 0, so there isn't a deviation greater than that. Let's go page down and see if it ever changes. So over here you can see it did deviate. There's 1, so it was outside of our specified limit, and so, but otherwise, okay, there's a few places that it did deviate, but otherwise it was in general pretty good. The other value that is output is this diurnal deviation. If you look here in help, it says this diurnal deviation channel contains a maximum diurnal deviation at each point. This can be compared directly with the flag channel, as all the values greater than the input maximum will have a flag value set to 1. So you can see here we set ours, what did we say, 2 nanotesla per minute, and you can see here where it deviates and it's 1, the deviation, the nanotesla reading is greater than 2 nanotesla per minute. Other things you can do here is look at the sensor noise, sensor data noise. So obviously, let's actually just close this. So this is the alternative data set we were looking at, so we don't want to look at it anymore. Let's go back to our original data set. Airborne QC sensor data noise. Our data channel is magnetics. So it would, I'd use this original micro leveled one. Fourth difference tolerance. I don't 100% understand what this means. I'll contact Geosoft and find out. I didn't get too much more out of the help file, but I know for it was smaller values. So let's hear. So I'm assuming, I mean, often differences are related to derivatives, and like the first derivative, I've filter highlighted all the noise. I'm sure this is checking where the noise is the worst. So I'm leaving it as normalized. Yes, I'm going to do it on a new map. So it's just pointing out where you've got noisy areas. Let's see how it plots. Again, and that was obviously too small a threshold. All of the data is shown as being noisy. Let's go back here, and if we do 1. So you see, you might have to play around a bit for your survey. Okay, 1 is too big. So we had 0.5 and 1, so it's somewhere between there. Return 0.8. I think 1 and 0.1, which was somewhere between there, so let's try 0.5. Okay, and so you can see areas, and this could be an indication for you of data you might not want to put too high a value on, although here it's so random, well not random but interspersed in your data, it might be difficult. But like if you had a large patch over here that was all marked as yellow, then I'd be a bit dubious about this data, that maybe there was some problem when they were flying in this area. So it might give you an indication of where your problem data is, but this one seems to be randomly dispersed throughout. Okay, and then just to go here to this last thing, batch apply, you can apply several of these at the same time, and plotting QC results is the plots that are generated here in case you want to come back at a later stage and plot the values.